Hello everyone, welcome to my talk about Repo Convergence. So let's start, we don't have a lot of time. My name is Shachar, I'm a software engineer. I work at Cato Networks, I'm a team leader there. We're hiring, of course, and it's a really good place to work. I love challenges, I always try to improve the development environment for myself and for my team. I also love cycling in Tel Aviv, and the traffic in Tel Aviv can be quite dangerous, so for all visitors, be aware. But I couldn't miss CPP conference. Yeah, and this is also my first talk in a conference, so I'm excited a little bit. Yeah, and also about the talk, there's a GitHub here. There will be a link in the end as well. With all the examples you see here, like this is a real project. You can view everything afterwards. So I'm going to talk about a journey as something we actually did. And let's use an analogy. About 80 years ago, Tolkien wrote a book about a hobbit named Frodo that needed to take a ring from the Shire to Mordor in order to destroy the one ring that ruled all the other rings. We are going to do exactly the opposite journey. We are going to start at Mordor like a chaotic place. And in 4 steps, we hopefully going to get to the Shire. And to do that, we're going to create the one repo to rule them all. So it's kind of opposite. Yeah, so what we are talking about, this is the product we're going to look into. This is a Cato VPN. This is like the GUI. This is how it looks like. Development started at 2015. This is a desktop application with many users, many active users. So this is an active project. And it's compiled, or we will talk about Windows and Mac iOS and Linux compilation for this product. So the starting point where we started, and also we talk about why we wanted to improve that. But before that, a little bit disclaimer, this is a talk about something that we actually done. And there's no absolute truth here. Like, I might say some things that might be like thank you, that some people might not agree with. So bear with me, I will explain why we did the things we did, and so on. So our starting points, we had 4 different repositories. This application had a common library that was common to all operating systems, and it had one repository without any build instructions inside that repository. We also had a Linux client, which was built using GCC and Makefiles with no special IDE, so Vim. Windows client, which has C++, C#, and was using Visual Studio as IDE and compiler, and also iOS and Mac that also had Swift code and used Xcode. So not only we had 4 different repositories for a single project, the connection between the repositories were not the same. Windows used a Git submodule. We'll talk more about the Git submodule soon. Linux just used a symlink to point to the other, to the common library repository. And iOS also didn't even use symlink, just assumed you put them in the same directory and hopefully everything will be good if you put them in the same directory, which is not maybe not the best way to put 2 repositories together. Yeah, so this is how we started. So what's wrong here? Why did we want to change this? So first of all, this method can waste some time when developing. When I want to start a new feature, let's say in Windows, I need to open a new branch in Windows repository and also in the common library repository. If I want to open a pull request, I need to open 2 pull requests, and working with submodule, with Git submodule can be tedious and not fun sometimes. Continuous integration is hard. What I mean by that is if you see in the previous slide, we have the iOS repository and the Linux repository that are not hard connected to the common library repository. So sometimes it's hard to understand when you need to recheck things. For example, if I make a new feature for Windows, I might have changed the common library. So now I need to also retest my Linux client, but maybe I didn't know that I need to retest my Linux client. So it makes this a little bit harder. It's one product, and we have 3 different ways to build it completely. So it's more knowledge you need to preserve inside the team, and it also makes the team a little bit more segregated because you have like instead of one team, multi-team that works each on other operating system. And sometimes it's not nice because it can turn into programmers' violence, which is not bad because people don't get hurt, but it can be embarrassing. So now that we understand how we start, we begin our journey. And at the first step, we want to simply put all the repositories in a single repo. So for this, we'll use this analogy of fishes inside an aquarium. For this analogy, the fish are the repositories we want to put inside the bigger repository, the monorepo, which is the aquarium. So we have 3 methods to do that. The first method is good old copy and paste, like just take the files, copy them into the new repository. So in this analogy, it's like cloning the fish and putting the new fishes in the aquarium. We have Git submodule, which is basically says put a reference in the main repository that point to the other repositories. So in the analogy, it's like a post-it note inside the aquarium that points to the other fish. And we have Git subtree, which is kind of combination of the previous 2 methods. You do make a copy of the fish, you clone them, but there still remains a reference to the older repository. We will look into it right now. So when we compare these 3 methods of making a few repositories, multi-repository into a one single monorepo, we wanted to know how easy it to use this method for day-to-day. This method keeps history. The project started at 2015, so we have 6 or 7 years of Git history, which we don't want to lose. And is it possible to merge from old repositories? Because, of course, this change takes some time. There will be a period of time that some of the people will work with the monorepo and some of them will work with the previous repository. So we still need an option to merge branches from the old repositories. So if we look at the copy-paste method, so of course the day-to-day use is very easy because you just copy the files and you have new files in your monorepo. But of course there is no history that like all the history is deleted, and also merging from old repositories, it's not easy. You're probably gonna need to use an external tool to do that. When we look at Git submodules, so for example, if let's talk about day-to-day use. So if we want to pull changes from the server with Git submodule, we do Git pull as usual, but we also have to do Git submodule update. And if you forget to do that, it's not fun. If you want to open a new branch, so you need to open a new branch in your regular repository and change directory into the submodule and open the new branch. So day-to-day use is not very good. It's tedious and it causes a lot of mistakes. But Git submodule, of course, keeps the history because it keeps the original repositories intact, and you keep working on the original repositories. And of course, it's very easy to merge from old repositories because they still exist and we work with them. With Git subtree, you need to set it up just once. And it needs to be done just from one team member, not everyone. So first of all, to set up subtree, you need to add the repository you want to add as a subtree as a remote. So here we call the remote Windows repo, and this is the address. Then we need to fetch the changes from the Windows repo. And this command, this is the subtree command, we tell Git to add the master branch from the Windows repo under the subdirectory of Windows inside our large monorepo. And once we did that, the files are actually copied into the monorepo, and we can work them, and they're independent than the files in the original repositories. So the day-to-day use is very easy. Once another team member will clone this repository, it will see like, it will look like regular files. And when we do that, we also preserve all the history in a nice manner, because also all the history is kept under the subdirectory Windows. So it's very nice. And it is possible to merge from all the repositories. This is the command. You need to do git pull with the strategy of subtree. And you tell them into this subdirectory, and you tell them the remote and the branch you want to merge from. So maybe it's not the most easy way to merge from older repositories, because you do need the Windows repo remote defined, but it's also not very hard. So it's quite OK. So when we compared all the methods to create one repository, we chose subtree. It looked like the most suitable method. And we are done with our step one. We have one repository that contains our other repository, Apple, common library, Linux, and Windows. All of them contains as a subtree, so all the history is also copied. Yeah, and we're ready for our next step. So in our next step, we need a build system. We want a single place to define compilation. We want if a Windows developer adds a feature, and because of the feature he adds a file or a compile flag to the common library, we want that the Linux or the Mac project will get those files or compile flag as well. We still want to preserve some flexibility per team member preference. Like if we had team members that said, I'm going to work only in Visual Studio, don't talk to me about anything else, or only in Xcode. So we wanted to have flexibility for that. We also wanted some additional scripting, like protobuf generation, to be part of our compilation. So if we look on the industry, we have a clear standard for that, Cmake. This is a poll from JetBrains from 2019. And we can see that Cmake is clear winner, and right after it, Visual Studio and Makefiles, which doesn't give us all we want. So of course we chose Cmake here. And this is a quick sneak peek of how we, also Cmake gives us a bonus of supporting C# and Swift, which is very, very nice. So this is like a quick sneak peek of how we used Cmake in our project, maybe a little bit trivial to people that know. So at first we just need to define like the project and some essentials of Cmake. Here we have some, this is like scripts to set up Cmake, set up compilation flags, definitions, stuff like that, which are common, and we are adding our common library. And we can have an if statement and add, for example, add a Windows directory only if we compile for Windows, and add the Linux directory only if we compile for Linux. And if we look further, for example, this is the Cmake file for the common library. Just look, let's look into it just to see a few features, nice features of Cmake that we used. In the first line, we add the unit test. In the second line, we have a function we wrote that generates a protobuf file. Basically, it takes a data.proto, and eventually will generate the file data.c. Here we have a add library, which creates a statically linked library called common lib, using the source files here. And the nice thing about this function, this is a Cmake function. We needed to write it only once, and it works for all operating system. And the nice thing, if we change data.proto file, it will know it has to regenerate data.c file, and it will know it has to recompile common library. This is a nice feature. And we can see this is how we added libraries to for linkage. And also we can, whenever we want, we can make specific OS-specific definitions. For example, here we only need Windows to link this library as well. Yeah, so we are done more or less with step number 2. So our third step is how we get our third-party libraries. So at our starting point, each operating system had different scripts to compile the third-party libraries. In Windows, it was Windows command line. In Linux, it was Bash. And in Mac, I think it was simply the system libraries. So this is not a good thing. We also had different versions of third-party libraries in different operating systems. And of course, we had code duplication. So in the third-party libraries, there are two main options. There is a VC package of Microsoft that supports around 1,700 packages. And it's very simple to use. And we have Conan of JFrog, supports around 900 packages. So they are not very different. It's looked like when we looked into it, it looked like a VC package is more built or was designed more for simplicity. It's very easy to understand, very fast to start using. But it's not as complex as Conan. Conan has much more features, much more ability to customize things. I do think that VC projects are closing the gap during the last few years, but for our need, we had to have Conan. For example, Conan enables you to set a lot of options in the libraries and also have a recipe version, different recipes per version of the third-party libraries. So at this case, we prefer to use Conan, so we chose Conan. And if we look, this is another poll from JetBrains. There is like no standard in the industry. You can see that Conan and VC package are both under 10%. Most of us use nothing or use system libraries. And I think it's something we need a standard for in C, C++. So this is like a really quick overview on Conan, how Conan works for people that may not know. So we have each package and version has a recipe file in the server. And each recipe file is coded in Python and can accept, actually what it does, it fetch sources, compile the sources, and package them into a binary package. Yeah, and the nice thing, each recipe file can support multiple operating systems, multiple build settings, and build options. And if we have a recipe and build parameters, we can build a binary package. So for this example, like this is a binary package of Windows Visual Studio 14, and this is Linux built with GCC. If we want to use Conan, so this is a command line that we might use. We give the package and the version. And in this command line, we ask the operating system to be Linux and the compiler to be GCC. We usually can fetch directly the binary package directly. We can also choose to download the recipe and build the binary ourselves, or we have to do it if it doesn't exist in the server. So how did we integrate Conan into our repository, our project? So luckily, Conan have a very good integration with Cmake. So basically, these two lines we needed to do in Cmake, and that's it. But let's break it down. So it uses the Conan file txt, which defines the actual libraries we are using and the versions of the libraries. You can also specify options for the libraries. For example, here we are asking Boost to be with exceptions and with file system. And there is the configuration file, which is specific per operating system. So for example, this is the Windows configuration files. And here we can define the compiler type and whatever we want about the build settings. And we can also specify like special options. For example, here we told them that libcurl needed to compile with schannel, but this will happen only in Windows, which makes sense because schannel exists only in Windows. So what do we get from this? I think there's several ways to use Conan inside Cmake, but eventually what happens is that Conan will set you a few variables. So this, for example, this is the include dirs for libcurl. This is the directories you need to include to link with libcurl. This is the libraries you need to link in order to link with libcurl. And the nice thing here is Conan knows that you also need this library in order to make libcurl work specifically in Windows. And even Conan will tell you what kind of defines you have to do to be able to use libcurl. So it's a very nice thing. It's when you try to add third-party libraries, you get stuck with those sort of stuff, especially when you need to do it not only in Windows, also in Linux and Mac. So it's really, really nice that Conan gives you all of that for free. OK, so we are done with our third-party libraries. But after we did all this, we were still not happy. Building different operating systems is still complex, still a bit too different between operating systems. There's different Cmake commands. For example, this is the Cmake command to generate the build folder for Windows. This is what you need to run before you start compiling. You give the source dir, the build dir, the generator. Here is Visual Studio 17 2022, and you need to write this exactly like this for it to work. Architecture and release debug. And of course, if you usually work in Linux or usually work in Mac, you wouldn't know how to do this line for Windows. There could be different build steps for different operating systems. For example, for Windows, because we use the C# project, we also had a step of NuGet. And that leads for different, like Jenkins configuration per operating system. When you write, when you have like the CI, it will have to do different steps, and in each step it will have to do different things. And also, with this approach, we basically, for example, we generate a Visual Studio project. So the most logical thing is open the Visual Studio GUI and compile from there. And we also wanted to be able to do everything from command line in an easy way, easy manner. So our solution is to write ourselves a small, minimal Python script called BuildAll. Really good name. So in this example, the Python script can get a version, doesn't have to, and get which configuration you want to build. In this example, Windows 64 bits for debug and release. The script will tell you what configuration it's going to run and what steps it's going to make. You can also, it's going to make all the steps, in this case, clean, Cmake, NuGet, build, package, and test. And you can, of course, you can tell the script specifically what steps you want to run. And once you do that, this is very satisfying to run in the script. Also, it's a very easy demo because it works in PowerPoint. So you can see the script goes by configuration and step, and do it step by step, and it tells you exactly what it does in the command line. So if you want to rerun this step, you can rerun this step. In this example, everything is success, of course, but if it fails, it will stop, and it will tell you where to find the log files. This script is very, I think this script is very strong, because with this script, it got very easy for a Windows developer to develop something, and then maybe he broke a unit test in Linux. So with this script, he can grab a Linux machine, and he can just run this BuildAll script, and he will have a compilation. He will have the error message from the unit test, and he could try to solve it and rerun the script and see if it really worked. Before this script, for example, we had to pass this bug from the Windows developer to the Linux or to the Mac developer. So basically, this script gives you a single interface to how to build your project. Yeah, so we did it. We started at Modder, which is a chaotic place that developers doesn't really enjoy to be. And in 4 simple steps, we use Git subtree to merge all our different repositories into a single monorepo, Cmake to have one single build system, Conan to handle our third-party libraries, and we still had the BuildAll Python script to give a single interface for building. And hopefully, we are now in the Shachar where it's much nicer to be and develop. So that's it. Thank you very much for listening. As I told you earlier, this is the repo, for example, of monorepo just like that. You can go in there and see an example. And you can, this is also my information. You can contact me with anything, especially with questions and problems about environment development and Git repositories. I really like those stuff. Yeah, and that's it. Any questions? Thank you.